Hello, good morning, good afternoon, good evening, wherever you are. A big welcome to all of you. My name is Laura and I'm delighted that you are joining us for today's ESPC community webinar. Today I am joined by Phil Seamark, who will cover the various types of DAX Fusion available today in Power BI and share some techniques and best practices. We love hearing what you guys have to say, so remember to join in on the conversation about today's webinar and more on X. Our handle is at ESPC community and our hashtag is hashtag ESPC24. Tweet us, at us and tell us what you learned. Don't forget to check out our Learning Hub, which is updated daily with the latest blogs, ebooks, webinars and how-to videos. You can access and view the Learning Hub by visiting our website sharepointeurope.com and clicking the Content tab at the top. Don't let the learning stop here. Continue to keep up and stay ahead by joining us for our next webinar, Fostering Trust in Your Data Ecosystem, Building Data Governance in Microsoft Fabric, with Martha Mungen. This webinar is the 6th and final webinar of Microsoft Fabric Week, and it takes place Thursday, February 22nd, from 11 AM to 12 PM CET. For more information on this webinar, you can check out sharepointeurope.com/Microsoft Fabric Week. The moment we have all been waiting for is finally here. You can now view the European Power Platform Conference 2024 programme. Get ready for an immersive experience, hot topics and trends, world-class speakers, interactive panels, engaging tutorials, networking extravaganza, and much more. View the fantastic lineup of tutorials, sessions, and networking by visiting sharepointeurope.com/conference schedule 2024 EPPC, and you can see the link there at the bottom of the screen. Here at ESPC, we want to spread the love this Valentine's. That is why we're offering you this limited edition one-time offer, a deal we know you'll fall in love with. So why not infuse a little love into your workday by securing 30% off your ESPC 24 ticket. 2024 is the year to rekindle the flames of your Microsoft 365 passions and inspirations. Discover innovative solutions and time-saving techniques, meet with peers to share and receive ideas, hear the latest news from Microsoft Corporate, and of course, gain genius insight from our knowledgeable speakers. And again, you can visit sharepointeurope.com/pricing, and you can see the link there at the bottom of the screen to snatch up this offer. So we will have time for questions during this webinar. So if you have a question at any stage, feel free to type it into the questions window and Phil will kindly answer it if he has time during the webinar, and if not, we can allocate a couple of minutes towards the end. Or I can always send on any questions to Phil via email, and as always, the webinar will be recorded and added to the resource centre, where you will be notified by email when it is available. So I can always include some questions and answers in that email as well if we do run over time. So I'm going to hand you over to today's webinar presenter, Phil. Hello, Phil, and thanks for joining us today.
Hello, thank you, and nice to be here. Thanks for inviting me. I'm going to share my screen and just hopefully this shows up as the correct one. Let me share screen. That's the right one. So hopefully you can see the slide deck that says Optimizing DAX Fusion. So the topic of today's session is going to be very much about DAX. It's actually going to be quite an advanced DAX session. So hopefully you're not coming at this from the very first time, never written a line of code of DAX. But the goal of the session is really to help you better understand what in particular Fusion is, to understand it better, and what you might be able to do to make your Power BI reports run faster. I know this kind of comes under the umbrella of Fabric, so absolutely, if you've got a Power BI report inside Fabric that you want to run faster, then this will definitely apply. But equally, it applies to Power BI today outside Fabric as well. And in particular, it's not uncommon for me in my role when I work with many customers, for them to say, hey Phil, we've got this quite slow report, it's taking too many seconds to load. And before they even show it to me, quite often I know ahead of time that they've probably got a very busy matrix involved somewhere on their report page with lots of columns and lots of rows and perhaps a whole band of filters and slices running along the top or in the filter panel. And the good news is we can typically optimize it, and there are many different approaches that you can try. But today's session, we're going to be talking much specifically about DAX Fusion. So I'm going to find my deck and fast forward to the next screen, which is here. Cool. All right, so the agenda today is going to be quite straightforward. So we'll start by diving a little bit into exactly what Fusion is, and then we're going to do an optimization exercise. So I have got what I just described to you. I've got a Power BI report using Contoso data. It's not especially large, but it's following what look like general good practice. We'll have a look at the visual, we'll have a look at the measures, we'll have a look at the model. And there aren't necessarily lots of red flags, but the performance isn't great. But then what we'll do in the optimization exercises, we'll go through a few changes and I'll explain them as I go, and we'll watch the performance improve as we go. And then we'll wrap it up with a little bit of a summary at the end. So first of all, let's jump across to DAX Studio and have a little look about exactly what Fusion happens to be. So if I go new query, and I'm just going to connect to a model. I'm not going to talk about the model too much here. I just want to run a few basic queries. So I have a Contoso model. I have a simple fact table surrounded by a series of dimension tables, the kind that you normally are used to seeing in these types of demonstrations. So let's first of all look at regular Fusion. I've got 3 queries here. The first query, what I'm asking it to do is group by the brand name column in the product table, and for every unique value in there, we're not applying any filters or anything, just go and figure out, I want to have a look at sales for each brand. I'm going to turn on server timings. This is a really useful feature of DAX Studio to give you some insight on what's happening when the query is running, how it goes about getting the result. The query plan is such. So let's have a look to see what happens when we run this first query. And we're going to clear cache on run each time. So the query begins. Now the model I'm running against is in direct query mode, and I'm doing that deliberately so that it's very easy to see in the server timings what are the important scans over the fact table. So the fact table is in direct query, the dimension tables aren't necessarily in direct query. Now this is taking a lot longer than it normally does, probably because it's just waking up something in the background. I haven't run this query for a few times. So just now that it's warm, I'm going to run it again. And we can see that it doesn't take very long. Now the results are to be expected. We've got a value for sales next to all the brands that appear in this particular column. But the interesting piece is the server timings, and this is what we're going to focus on. So to get the data we need to produce this result, we only performed one storage engine scan. And the storage engine scan, for those familiar with SQL, looks like this. So we grouped by brand name as expected. And then what we did was we performed a sum aggregation over the sales amount column. And the rest is just where we're getting how the tables relate to each other and where they're from. So this is very nice and well behaved. There's no fusion taking place here, but we're performing a sum of sales. Now if we want to run a very similar query by grouping by the same column on brand name, but to perform an aggregation over a separate column, how does that look in our server timings? We get a single storage engine scan again, and it looks very similar, but this time our aggregation is not over the sales amount column. We're performing sum over sales quantity. Okay, this is all good. No need for fusion. These are running very snappy. I'm happy with this. But what happens if we try to run a calculation where we want to do 2 metrics at the same time? We want to do a sum over sales, and we also want to do a sum of quantity. Now, if we go back far enough in time, this particular query would have generated 2 separate scans. One to that would look like this top scan that we looked at, and there would be a second one that would be identical to the second query I ran. But regular fusion kicks in here and is smart enough to generate a piece of SQL that groups by brand name, so that's expected. But what it's also doing is it's combining the two aggregations into the select statement, because our filter and the structure of the query is identical. It's makes sense to just append another aggregation, seeing as we're going to these exact same rows in the fact table and the dim product table anyway. So this is regular fusion, where we can actually combine the aggregations on the select part of the statement, because we know everything from here down is the same between these two. That's why we were able to fuse those two together. So that's regular fusion. The other one that we have, which is a relatively newish concept, is called horizontal fusion. So here what's happening is I want to perform a calculation over the sum of sales, but I also want to get the sum of quantity, like we just did. But for the sales, I only want to look at a data that belongs to rows where the color is red. But for quantity, I don't want to use the red items. I want to get this quantity from blue. Who knows why I'm doing this? It doesn't matter. Horizontal fusion kicks in here, but we'll see exactly where that takes place. So we have only got a single call, which is great. This is exactly what we're looking at, what we want. And if we study the SQL statement that gets generated, that's fused together, there's a couple of things going on. We are grouping by brand name and color name this time round because of the filter on the in the calculate statement. And because we're grouping by them, we've got them up here. Regular fusion is kicked in because we're seeing the aggregations over the sales amount and the sales quantity column. But the really important thing for horizontal fusion is here. We've got an in clause on the where statement, because what horizontal fusion is doing is saying, I'm going to make one round trip and I'm going to go get all the rows for both red and blue. And when they come back, I'll sort them. So if I was to take this particular query and run it in SQL, what I would see is a row for every combination of brand and color name. And then in the columns, I'd see the sales amount and sales quantity. Then what would happen once that intermediary row comes back from the storage, which in this case is SQL, DAX kicks in and post-processes that intermediary table and then goes and figures out, well, this measure here, we're going to filter the intermediary table that came back, but only look at the rows that happen to belong to red, and we'll use the sales amount column. And then for this calculation, we'll go back to the same intermediary table. This is happening now in the formula engine, and we're going to go extract the rows that belong to blue, and then we'll go and grab the quantity. So it was quite nice. But unfortunately, things are a lot more ragged and a bit not so neat, because what can happen more likely is, we'll just adjust this a little bit. Now we've got the same calculation. Calculate quantity. But this time around, my blue line has got an extra condition. And what that now means is that the from and where clause for here are no longer identical or no longer similar enough to be able to fuse to the from and where clause here. So what's going to happen now when I run this particular calculation is horizontal fusion will have an attempt, but it will give up and say, no, I'm not quite sure how I can do this automatically for you. And what that means is we will get multiple storage engine events, multiple reasons to talk to the storage engine. So here we go. Here are the two SQL statements. And if we look at the first one, the where clause, hopefully you can see this okay, is filtering a fact table where class name is regular and color name is blue. So that belongs to this calculation here. And this is actually performing only an aggregation of quantity, which is producing this calculation. And the other storage engine event is probably grouping by the same things, but now what's happening is the from and where clause don't have the need to have a filter on class name, for example. So this gives you an accurate result. There's no problem with this. for accuracy. The problem is when you start having more and more storage engine activities, they don't necessarily parallelize that way. They can really start to chew up an awful lot of compute, and things can go south from there. Now, the good news is we can fix horizontal fusion by applying a very specific DAX pattern, which I call the X pattern, where we can control what the storage engine does and control what the formula engine does to allow us to be able to fuse situations like this together. So I'm going to show you a longer query now. Hopefully you can keep up. Okay, so I'm rewriting, in this case, my sales and quantity measure. So let's focus on the sales measure. At the core of my sales measure, I have got exactly the same aggregation taking place. We're doing a sum of sales amount. But what I'm doing is I'm wrapping this inside an iterator, very specifically inside an iterator that's going to iterate over every combination of color name and class name. So this block of code here is going to be what we push to the storage engine. This is really important. And because we clear filters, we're not doing it just for the red and blue. We're actually doing it for every single color combined with every single class name, which is a bigger intermediary table, but it's going to do one round trip. And when it comes back, we can then post-process that in the formula engine to make things more efficient. And that's where the second part of this X pattern comes in. Here, this filter logic applies over the intermediary table that we generate in the storage engine, and then filters that for what happens to be in the filter context for wherever the calculation is being called from, like a cell in a matrix, for example. Wherever we use this, we need to repeat the same X pattern around it. So in my sales measure, I have the sum X of all color name and class name, and then I have my calculation, and then I filter it. Down here in my quantity, I have exactly the same pattern. I'm doing a sum X, an iterator, over every combination of color and class. The only difference is I'm now performing a slightly different aggregation. That's okay, they're going to fuse. And of course, I have the work that I'm pushing to the formula engine as well. But very much the only difference between all of the lines in this measure and all of the lines in this measure is only the calculation. That's the only difference between the two. So let's see how that behaves for real. So down here, I've got my calculation again. So I'm grouping by brand name. I want to have a column that shows red sales, and I'm going to calculate sales where color name is red. I'm going to perform calculate sales again, but where color name is blue and class name is regular, and I've got a different one over here. And this is really important to understand what are the appropriate groupings you need to push into your formula engine to design that piece of SQL. And we need that storage engine to focus on color name, class name, and brand name. And that's why color name and class name are included in my, so there's a direct correlation between color name being used here and it being included in my SumX pattern. So let's see how this performs. Can this beat 2 storage engine scans? Let's run it. And I'll actually run it a second time because I think this is just still probably waking up some direct query type things. All right. Now there are more storage engine events here, but these scan events, they're all very, very quick. They're actually super fast lookups of dimension values. I'm not concerned with these because these don't touch my fact table. So they're not slow. The one I really am interested in is anything with SQL here. So let's have a look to see what got generated with this X pattern. It's looking pretty good actually. So we are generating an intermediary table that's grouped by brand, class, and color name. So brand, class, and color name are up here. And regular fusion is kicking in. So we're getting sales and sales amount and sales quantity. And that's generating. If I cut and paste this over to a SSMS or my Fabric SQL endpoint query view, what I will see is a 5-column table, and we'll have as many rows as there are brands, classes, and color. And for each combination of brand, class, and color, we will have the appropriate sales amount and sales quantity. And what I can do with that is not only produce the correct values for here, it'll actually also handle things like subtotals and totals, and really minimize the number of storage engine events that we can apply. So that's hopefully a really quick introduction about what the concept of Fusion, what it is we're trying to achieve, especially in minimizing and combining these storage engine events to as few as possible if we can. So let's go to my optimization exercise. So what is Fusion? Here is my very ugly report. I am not a report designer. I actually don't try very hard because I think it's more embarrassing when I do. But what have we got going on here? We have a busy matrix. It's not unlike many reports that I get shown when, hey Phil, we've got a slow report, for example. There's a lot going on here. I've got calculation groups because I want to have the ability to select a month, say May 2008, and there's a filter on brand name for why not. I've got a dynamic period switch, so I can either choose a comparable month, either the previous month or the same month last year, and then have a calculation which shows you what the percentage difference is, positive, negative as a percentage, between those two values. I'm also going to have 5 metrics. I'm going to have sales quantity, count of sales, return amount, return quantity. It actually stretches out to the right. And on top of that, still again, off on the side in the filter panel, I've got a measure as a filter that's saying, I only want to see the top 5 stores by sales. So there's an awful lot going on in this particular calculation. All right, so let's jump over to Power BI. I have my before report, and I'm going to turn on Performance Analyzer, and I'm going to start recording. And I only have one page here. I'm just going to open it up, and it is cached. So I am going to go to DAX Studio and connect to that report, clear the cache, and then we'll run it again so we get a fair reflection on. There we go, clear the cache. Okay, and let's focus just on this. So I'm going to go analyze this visual. So as I mentioned, we've got this ability to select dynamically what we would like to compare our current month to, change the brand. We've got a filter over here saying only show me my top 5 sales by stores, etc. This typically takes about 60 seconds. And what we're going to do is capture that DAX. We're going to take it over to DAX Studio, run it there with the server timings on, which is probably, unfortunately, going to take another 60 seconds. I don't know if there are any questions in the chat window, but failing that, I can always go to my repertoire of terrible dad jokes. Let's see if the matrix timing will save it. This is by far the slowest query that we're going to be running in today's exercise. And when I run it in DAX Studio the second time, it will be probably a better reflection of any sort of warm cold cache with the direct query. 60 seconds, that's about what I recall actually. Now I'm going to capture this DAX and I'm going to take it over to DAX Studio and turn on the server timing so we can see exactly how many of those fact table storage engine events were generated. So I'm going to paste that in here. So what are we doing here? We have a calculation group to allow us to do the period comparison and the difference. We've got some filters on continent. We've got the top 5 measure thing happening here. That's as a filter. The month that were picked, etc. All that goodness, and we have our 5 metrics, including the format string version. So I'm going to kick this off and get it running. I probably should have done that first, actually, and then then gone through it. If I click it again, I think I had something highlighted. Okay, and this probably should take anywhere from 45 to 60 seconds. Now, one thing I do want to show you about the model is this particular model is star schema, but my relationships and my storage modes aren't really set very optimally. Like here, what I have is my fact table in direct query, because let's just pretend it's billions and billions of rows. In reality, it's probably a million or two. Off the top of my head, I'm not quite sure. But I've got the dimension tables in import mode rather than dual. And I've also got the relationships set to weak relationships, buy, die. For this particular query, it probably produces the correct result, but you do have to be wary of it. But it's not uncommon for me to see this in examples when I come across queries. So the very first thing we're going to do is just simply convert these dimension tables to be dual mode, so they can run in both direct query and import at the same time. And we're going to fix the relationship. We're not going to change the query at all. So I think that's completed. It took 55 seconds. Let's have a look at the server timings. This is big. So the total number of storage engine queries to produce that matrix, to go and figure out the correct value to show in every single cell and subtotal and subtotal, with 337 queries. Now, they're not all SQL queries. We've got scan, SQL, scan. So scans are typically any action where we needed to go and grab data from a dimension table to help us with our plan. But anything with SQL is a need to go and get data from the fact table. And if I sort by duration, because that's an easy way to find them, we can get a sense of how many SQL events there are. And none of them individually really took that long. The slowest one was 5 seconds, but most of them were 2 seconds and less. But because of the sheer volume of these SQL events, and even if you sort of look here, there's a lot of repetition. There's not a lot of fusion going on. So off the top of my head, there's probably about 100 of these SQL events. What can we do to get these down? So as I mentioned, the very first thing is let's have a look at the data model. Let's fix the relationships. Let's put the dimension tables into dual. We won't change anything else. So I've got 2 PBIX files here. One's a before and one's an after. We're going to take this query, which we just captured, and we're going to create a new connection. And we're going to connect this to my after. And we're going to paste in exactly that query. Now, the only thing, as I mentioned, we've changed is the relationships and the storage mode. We'll turn on server timings and we'll have a look to see what impact that does. I mean, what we were seeing, 55 seconds and 60 seconds. Query started. 12, 13. I like to watch documentaries. I saw one the other day on how old ships were made in the 1900s. It was riveting. Aha. Okay, what do we got here? 18 seconds. So it's quite a big jump. And the server timings for this, and just trust me, the results are correct. We dropped from 334-ish down to 124. Significant jump, 55 seconds down to 18 seconds. The SE jumped down as well. Let's have a look to see how many SQL queries we actually have in here. There's still a lot, but there aren't as many. And there's definitely some opportunity for fusion in here. We're getting probably all the various combinations of what's being used in the row header, the column header, the slicer up to the top, the top 5 store names, etc. There's an awful lot going on here. So what I want to do now is, now that we've fixed the model, now let's start focusing on the DAX. And the first step we're going to do is replace the calculation group. So the calculation group currently has 3 calculation items. One for just itself, to just return the selected measure, so for the current month. The second calculation item is just for the period comparison. And the third one, in fact, I can probably bring up tabular editor. And somewhere here, I can view the expression editor. So currently, the selected measure just returns sales quantity or measure or whatever. Then for the month to compare, we go and have a look up a the slicer that's on the canvas about whether they want the last year or the last month, and we just use same period last year, same period previous month. And then finally, where there's a calculation to do the comparison. So let's get rid of the calculation group. Why is that? Calculation groups at the moment, with the engine as it is today, block some scenarios where we can fuse them together. So what might this look like if we rip that out? So what I'm going to do is create a new connection and grab some different DAX, which is going to be version B. And we'll have a look at the measure, because I think this is kind of interesting. What about there? Sweet, and we'll paste this in. I'm going to share this code afterwards, because there's a bit to sort of follow here. Copy and paste. Nope, it's doing that funny thing that I've seen before, where the paste doesn't quite work. Let's have a look at the calculation first, the model. So in the after, what I have is version B is what we're up to now. Version B is the same as version A, which is the fixed relationships and storage mode. But version B, we rip out the calculation group. So what I have is I have a matrix measure table over here. And if we have a look at the matrix measure, it is just a disconnected table with 5 values in it: sales, quantity, transactions, return amount. And I can drag this column to the column header of my matrix. And that can be read by my calculation. And if I have a look at my calculation, it's pretty straightforward here. It's all based around a switch. So I have a variable that goes and figures out, well, what column are you in? Are you in the sales column or the quantity column or the count of sales column? And then based on what column you happen to be in, we'll return the appropriate measure. Now, this is really important that I've deliberately true. There's no else branch. Everything's very cleanly defined. If you have else, then that can that can cause problems for Fusion. And also, I didn't just put the calculation straight in the switch statement. I assigned them to variables and used variables in the switch statement. Fundamentally, that just looks like same thing, but it's not. It's really important that you apply this pattern and use variables inside the switch statement when you're using this kind of approach. Outside of this core measure, I have a current month version of the measure, which just calls that core measure we looked at. I have a comparison month that goes and figures out, well, depending on whether the month offsets -1 or run that core measure we just showed you, but over the date adjusted, and then we have a comparison month like this. So what I'm going to do is turn on my performance analyzer and jump to version B. So this matrix now includes the calculation group ripped out and replaced with what I would describe as a more older-fashioned disconnected table approach. And trust me, these numbers are correct. I'm going to reanalyze that visual so that we can capture the DAX, and hopefully this copies and pastes nicely over to DAX Studio so we can see the difference now that this makes to the plan. And it starts to get pretty interesting. Cool, that pasted in. So that's nicely. So previously I had a calculation group here in the main summarized columns, but otherwise, now we're calling these version B series of metrics. Turn server timings on, tracer started, and run. Oops, I had something highlighted, selected. Try again. So we started at 55, 60 seconds. With a clear cache on run, we're now down to 10 seconds. And the server timings starting to look pretty tidy. 13 total, that's including the dimension scans and the fact SQL lookup. We only got 5 in fact here. They're not particularly long. And when we have a look at these, what am I looking at here? This first one's grouped by store, and it's getting sum of sales amount. This one here has got some regular Fusion kicking in, but it's grouped by continent name and store. This one here, just continent name in Fusion. So what we're seeing is subtotals and other needs to sort of try and collectively organize this stuff, but we're getting there. So the next trick is to remind myself, we're gonna, the core measure didn't use my X pattern. Remember my sum X pattern with the all with the class name and color name in the example. Now we're going to change our core measure, so it's not using that simple default approach. We're going to introduce the X pattern to try and improve our ability to fuse across here. So what does that look like in the same model? So we're not changing the model here. So I jump back to here. Now we're looking at the version C version of these calculations. So the comp measure is no different, really. The current month measure is exactly the same. We're just calling the version C of the core measure. The comparison month is the same as what we previously had using, but what's different now is the core measure. It's looking a little bit busier, but trust me, it's not so bad. And if I jump back and forward, where previously I could simply just do this, now what I'm doing is for each of these measure 1, measure 2, measure 3, I'm introducing the sum X approach. But I had to use nested sum X because previously the example I used, both columns that I needed to include in my intermediary table came from the same dimension table. Here in this example, like a more production matrix, I've got columns from different dimension tables that I need to pull together into my intermediary table to go and get all the rows. And you know, if I only had one chance to talk to the storage engine, what would my one table look like? It would be grouped by every value in my month, in the month column of my date table. It would have store key and store name. They'd probably have a nice one-to-one correlation there. My consonant name, because we're performing a filter on that. and this box here, again, is exactly the same for all of my 5 measures. The only thing that's different is the calculation that's contained within them. And I'm including here the post-processing. This work here, once we've got the intermediary table, applies decides what from the intermediary table do we need to be able to produce the correct value for my measure 1, which down the bottom gets returned with the same switch over what my measure is. Okay, so that's the only difference. So let's see how this one performs. So we've got performance analyzer still turned on. So let's jump to version C. That looked like it was cheating. Let's run it again to capture the DAX, but we'll take it to DAX Studio so that we can have the clear cache on run and see exactly what's going on with those storage engine events. How are we going for time? We're going good. Well, something's made it run slow. I think actually, oh no, I was going to say, maybe it's stuck. Okay, I do actually have the DAX saved, so if that's taking too long, I think something's just tripped up. I'll go off the page and back on it. Otherwise, what I'll do is I'll go to DAX Studio again and create a new connection. I must be getting late in the evening after. Okay, cool. Paste that query in. Nice. Okay, turn the server timings on and run it. Oh, I've just got some typo here. No, this is actually an older one. Sorry, I'm going to see if my DAX matrix arc. Yeah, it's finished. Wonderful. Copy the query. It's not going to be 56 seconds. Something is a bit strange here on my laptop. I'm going to control and delete, paste in the query. This is all version C measures. Yep, wonderful. Server timings are on and run. Query started. We've got the clear cache going. So it's definitely slower than the last one. But what I'm expecting to see is where previously we had 5 storage engine events, this should only actually generate a single storage engine event. Now, normally, when I'm doing this not on camera and on a recording, this takes about 10 seconds. So we've kind of like, we've gone forward a step in the fact that we've reduced our storage engine events, but we've gone backwards because it's slower. And if we have a look at it, sure enough, there is a single storage engine event. Now, this is really interesting because it shows that time intelligence can be done with period comparisons with just a single fact table storage engine event, which is good. But for some reason, the formula engine is taking a long time because we got our intermediary table here. Now, this intermediary table is nearly right. It's fusing, it's doing regular fusion, which is cool. So it's fusing all of our aggregate columns together. It's grouping by continent, first name, and store key. But the problem is the combination of continent names multiplied by the combination of months, multiplied by the combination of store keys, can make the intermediary table quite large. You actually even have to be careful that it doesn't bust the million row. And the larger this intermediary table it is, the slower or the longer it takes the formula engine to process it, to go and extract what it needs. So this is good in the sense that we've got less fusion, but as I said, we've gone backwards because it's currently too big. So what are we missing? We only really care about 3 months because we allow the end user to pick a month, and in my case, I think I picked May 2008. And if they select a month, I only ever really need that month, the previous month, or the same month previous year. I don't need to get every single month that's potentially is in the date table. It could be quite large. So ideally what I want to be able to do is inject a where clause to reduce the size of my intermediary table down significantly. And a really neat trick to be able to do that is using a time intelligence table. So what that looks like, if I jump to my model, and I've got blogs on this that have got examples. Go back to after and see the model. Up here, so we haven't used this table yet. We're going to now, instead of filtering by the first dated month in the date table, we're going to now actually filter by this month and then allow this to apply a physical relationship. This is really important. And even though this is a many-to-many or a weak relationship or however you want to describe it, this does in fact help our calculation. Let's have a look and see what the table looks like. So the TI table is here. Here, TI table. Okay, so I've filtered it. There are a lot more rows if I clear filters, but for every given unique value in the axis month, and this is the column we use in our slicer. So if you happen to make a slice on the May 2008, which is what the report has done, maybe if I untick this and scroll down to May 2008, what in fact is happening under the covers is this column here is going to apply a physical filter across to the calendar table, only many-to-many because it's going month to month, and then that's going to get injected into our SQL statement in the form of a where clause. So I do need to make some adjustments in my version D. So my version D of the calculation is not much. It's just using my TI table, where previously I was probably using my date table. In fact, see here. So here I was probably extracting the date table, and I was grouping on the the month table and the date column, and that flows through. Whereas now in my last version of optimizing, I'm actually using the the TI table, and that's going to flow through. So where previously this said probably date, and I do have an offset in my TI table to really help that -1 or -12, depending on what I'm trying to calculate. But otherwise, everything else is the same. So let's see what that looks like in terms of a query plan. So we'll go to D. Okay, it was probably cheating. So let's run it again. Yeah, because it was just, it had, the visual cache was kicking in. It was probably just redisplaying the results I had from last time. I probably could have just selected a different month. Now, for some reason, this is, again, taking much longer than it should. I suspect something at my SQL endpoint is kicking in. Now, so let's take that query. This is going to be the last one, and pop it in here. So as a new query to the server timings. Okay, so we're using the D measures, but now we're using a slice on the I keep bumping this, and my speaker keeps turning off. Now, normally this takes about 1.2 seconds. Not quite clear why it's spinning out at me. I'm going to run in a second time. No. Oh, okay. 3 seconds or 2.5 seconds, 3.9 seconds. Something's a bit slow. Now, the good news is we only have one SQL statement, and that SQL statement is very fast. The difference between this single SQL statement and the last one is that we now have a where clause. This didn't exist previously, and this can greatly reduce the result set size of that intermediary table, so therefore makes it a lot easier for the formula engine when it kicks in to post-process. And I wonder if I might just change the power settings on my laptop and see whether that's causing a problem. Balance and best performance. Well, again, because this is suggesting it's spending all its time in the formula engine. I mean, yeah, trust me, today I've been running this and it's been taking 1.2 seconds, one call. But compare with this with the original DAX that we captured, the original query plan that we captured for that first version of the matrix, it's just spectacularly more efficient. So let's jump back to my slide deck. So what do? We had a busy matrix, we had 5 metrics, we grouped by store, filtered by user selected month, filtered by brand. We had a dynamic metric. We were using calculation groups to help with time intelligence. We were using a measure as a filter. This is normally very, very inefficient. We started with a model like this, lots of storage engine queries, very slow, very expensive, a lot of compute. Imagine one person looking at this, let alone 10, 50, 100 people looking at this report. Then after we fixed the relationships, we actually put them to dual. This is showing them all in DQ. We fixed the relationships and that brought things down significantly. And then we went and optimized the DAX. The key changes in DAX were we used a measure table in place of the calculation group, which gave us still the same number of rows and columns and the same values, but allowed Fusion to behave a lot better. That got us down to 5 fact table SQL scans. Version C, which was, we introduced the EX pattern, that got us down to a single storage engine event, but it didn't have a where clause, so the size of the intermediary table was going to be very large. And then finally, we introduced a physical table with a physical relationship that helped us craft a beautiful storage engine. It was like a piece of art, I think, that piece of SQL to give us the perfect piece of data to be able to then generate all that we need off all the busy matrix visual. So in summary, use appropriate tools, like use DAX Studio the way I was doing to and the optimizer to capture your DAX and study the DAX and have a look at the the profile, and don't just look at the number of storage engine events, have a look into them. Identify the ones that are using your fact tables, and then figure out how are they all being grouped. And then you can start coming up with the X pattern, where if I was to predefine the grouping for that matrix, we can certainly improve performance as we did. Yeah, always check your relationships and storage modes. That was our step one. We spent some time just understanding, where the differences between horizontal and regular fusion, where the gaps are. The X pattern to allow us to control what the storage engine does and what the formula engine does. Consider that time intelligence table to help, but it doesn't have to be time intelligence. There could be other variations of slices that you can add on a table, the physical relationship, to help craft that storage engine event. Dynamic format strings, something I didn't actually mention in the pattern, is in my measure table. There was a column there that allowed me to take advantage of dynamic format strings, because I wanted my sales amount to be shown as a currency, my quantity amount as an integer, and so on. Switch else, be careful of else statements in a switch if you can help it. There's try different variations of if and switch to be able to eliminate the need for a catch-all type statement. If you have to use it, you have to use it, but you're probably going to get penalized with some performance and Fusion. And yeah, use variables. Definitely use variables with that switch statement to figure out the calculation, put it into variable, and then just use the variable inside the switch statement to again reduce Fusion. Takeaway: should you apply these techniques all the time to every model? Absolutely not. No, this is probably the reserve of those extra special reports that are only going to be looked at by the entire company, that are going to get looked by a lot of people, that if you do have inefficient techniques, the amount of compute is just going to be something that you really want to be able to handle. It takes a lot of work. What you're gaining is performance, but you're sacrificing flexibility, because you're actually handcrafting or overfitting to some degree the metrics using that X pattern to the matrix. You're almost creating a dedicated set of metrics just for that measure. Other visuals other visuals may benefit from it, so you might get that gain, but it does come with a cost. So that's why I wouldn't recommend it for every single report. However, if you do have a slow running report that does involve a matrix and you do want to speed it up, then you can use some of all of these techniques. Equally, you're sacrificing code maintenance. The beauty of calculation groups is you can minimize all the measures. What I'm suggesting here for performance is creating a lot more measures, although I'm able to minimize that with switch and using that core measure being able to be called from other measures. And while I use direct query here to help demonstrate in the server timings the storage engine events I was interested in highlighting, because they would be SQL, the same techniques work equally well for import and direct lake too in Fabric. And as you saw, time intelligence, period comparisons in very complex scenarios can still be solved by efficient, highly optimized storage engine queries that you can control and craft. So that's my session. So thank you very much for jumping on. I'm more than happy to take questions, feedback, clarify anything, or is everyone asleep?
Yeah, thanks a million, Phil, for a great presentation. So as Phil said, we have a couple of minutes now to take some questions. I don't see any in here at the moment, but we might give people the chance, just a minute or two, to pop in any questions should they have any. But just on behalf of the ESPC community, Phil, I just want to extend a huge thank you to yourself for taking the time today to carry out this webinar. I know it's a late one where you are in New Zealand, so we really do appreciate it.
No problem. And as I said, in my role on the CAT team, I quite often get involved and get called into very large global enterprises who have got reports that are not just going to a small department, but in massive organizations. So they quite often have reports that just need to be really tuned to the max for as efficient as possible, use the least amount of compute, be as quick as possible because you've got high concurrency. They're trying to maximize their spend. So, why buy a P5 when you can, get the report running much faster, more efficiently on a P2 or a P1 even. Potentially use query scale out to get into the mix as well. Aggregations can come into play. There are additional techniques that also work well with this. So, this isn't the only option or tool that you've got. I just find fascinating to see what you can in fact do just simply by focusing on Fusion, the different kinds of fusions. And it is always fun to be able to say, hey, that report did take 60 seconds now, and it takes often sometimes even less than a second. Some of our customers work with organizations where their data is stored in a tool that charge you per query. So being able to minimize the number of times your Power BI report talks to that query using these techniques can also save you money. But like I say, you're sacrificing flexibility for performance. So just make sure you assess that correctly, stand back and go, which is appropriate way for me to solve this report based on its audience, based on the data, based on various things as well.
Fantastic, Phil. So I don't actually see any questions coming in here, so you must have covered everything. So what I might do is I'll wrap up the Q&A there, and we will finish off the webinar. So that is the end of today's webinar. Thanks to everyone for joining us today, and I hope that you'll join us again soon. Bye for now.
Yeah, see you later. Bye-bye.